Hi, my name is Jennifer von Mengershausen. My GitHub username is jennygiri and my EDX username is jenny_VM. Today's date is July 12, 2026, and the incident I'm covering today occurred in July 2024. There is no specific CVE number for this event because it was not a traditional software issue being exploited by hackers, but rather a catastrophic configuration update failure. What you can see here is not on your side. All good. This is just something that pretty much sums up the whole issue of this topic. Here we see the table of contents, so I will briefly explain why I chose this topic, what CrowdStrike is, especially the Falcon sensor, why in my opinion this case matters. Then we go on to what happened on July 19th, 2024, leading to the technical root causes and real-world impacts. Then we will cover the question what failed in QA and deployment and what lessons have been learned. So I chose this topic because it directly connects to one of the core themes of this course. It's trust. We spent this class learning how to secure systems against external threats, but this incident shows that the very tools we install to protect us, especially those running with kernel-level privileges, can become our single point of failure if not correctly validated. This relates specifically to our discussion on system security, availability, and the software supply chain. So maybe we should briefly cover what cybersecurity is first. So cybersecurity is the set of measures, technologies, and processes that protect systems, networks, programs, and data from digital threats that aim to compromise confidentiality, integrity, or availability. Given that, the CrowdStrike case absolutely fits this. It's a failure of security software that damaged system availability and created secondary security risks. I chose this topic because it relates to securing systems and the software. The CrowdStrike incident is a strong example of how a security tool with privileged access can cause a large-scale outage if an update is not properly validated. It helped me understand the balance between rapid threat protection and system reliability. So, what is CrowdStrike? It is a leading cybersecurity firm that provides a cloud-delivered endpoint security platform. Their software is used to detect, prevent, and respond to threats on devices running on Windows, Mac OS, and Linux. Unlike traditional antivirus that relies solely on signatures, CrowdStrike uses a lightweight agent to feed telemetry into the cloud, allowing security teams to investigate and correlate suspicious activity. What is their Falcon sensor? So this is the installed agent. It monitors process behavior and endpoint events to catch attacks early. Crucially, in this incident, the problem affected the sensor's privileged Windows side logic, which is why the failure had a system-level impact. The outage was triggered by what CrowdStrike calls a content update. These are not full software updates, but rather rapid detection rules update pushed out to improve protection against new threats. A faulty content update, which was not validated safely enough before broad release, triggered an entire global outage. So this matters because a bad update in privileged security software can crash the system itself. And on July 19th, 2024, this is exactly what happened. Like this. Okay, but what happened on July 19th, 2024? CrowdStrike pushed a faulty content update for Windows hosts and affected machines began crashing. You saw a lot of news like this. Oops, this was a little bit too much. So, the issue impacted Windows 10 and later systems. Mac and Linux hosts were unaffected. Approximately 8.5 million Windows devices entered a blue screen of death loop and got stuck in restarting state, unable to boot normally. It is important to note that this was not a cyber attack, it was a software failure. However, it did create a dangerous follow-on effect. Attackers immediately tried to exploit the chaos with phishing campaigns. CrowdStrike's chief threat hunter quickly published a manual workaround over here, which involved booting into safe mode, navigating to CrowdStrike's driver folder, and deleting a specific .sys file to break the crash loop, as you can see here. And they also confirmed they are no longer pushing the faulty update, so they can really focus on fixing affected machines. Now we will be looking at a technical root cause, and we find a parameter mismatch. a newly introduced inter-process communication, also called IPC, template expected 21 input parameters, but the sensor code supplied only 20. This created a hidden mismatch that was not caught during testing. Why did it stay hidden? Well, because earlier deployments did not trigger the issue. The 21st field used wildcard matching. For further information, here you can see what wildcard matching is. A wildcard, like asterisk, matches any sequence of characters, so the system didn't care that the 21st input was missing. However, on July 19th, a new template instance introduced a non-wildcard criterion for that specific 21st field. This caused an out-of-bound memory read in the csagent.sys driver, which led directly to the system crashes and blue screens. And because Falcon operates at the Windows kernel level, this failure didn't just crash the application itself, it basically crashed the entire operating system. The incident spread so widely for three reasons. First, Falcon runs with kernel level visibility, so failures are catastrophic. As you can see here, it's basically the main thing. Second, CrowdStrike serves a massive number of global organizations. Third, this was a rapid response content update deliberately designed for fast operational deployment, which unfortunately increased the speed of propagation. The real-world impact was enormous. We saw businesses continually disrupted across aviation, healthcare, banking, and government sectors. The US Cybersecurity and Infrastructure Security Agency, or CISA, officially described it as a widespread IT outage affecting Microsoft Windows hosts. So when you've been, by the time, at an airport, this was all you can see. So what specifically failed in quality assurance and deployment? I want to highlight 4 key breakdowns. First, the internal content validator tool had a critical bug. It failed to detect a mismatch between the expected 21 parameters and the supplied 20 parameters. Second, testing was insufficient. The validation suite only covered scenarios using wildcard matching. It never tested what would happen if that 21st field contained a specific non-wildcard value. Third, the deployment strategy was fundamentally flawed. They pushed this faulty update globally, all at once, without a staged rollout. In the industry, this is called the Big Bang deployment and is against every best practice for large-scale systems. Fourth, there was a dangerous human factor, baseline trust. Because 3 previous similar updates had worked flawlessly, the team skipped additional dynamic checks. They basically just trusted their past success, and this was leading to a complete disaster. This brings us to the critical lesson learned and my recommendations to avoid a repeat of this outcome. First, we need to comply time and runtime validation. The system must enforce that the number of supplied inputs strictly matches the expected number before any code executes. Implementing runtime bounds checks the content interpreter would have safely stopped the process instead of crashing the kernel. Second, testing must be exhaustive. Organizations need to expand their test suites to include non-wildcard matching for every possible data field, rather than just assuming that wildcard coverage is enough. Third, and perhaps most important, is deployment strategy. All rapid response updates must be subject to mandatory stage rollouts. This means starting with a small canary group of internal devices monitoring for errors during a break-in period and having automated rollback gates that instantly revert the update if any crashes are detected. Fourth, address the cultural complemency. Never rely on baseline trust from prior successful deployments. Every single rapid response update must be treated as a high-risk chance and validated as if were brand new. Finally, give customers more granular control. Organizations should have the ability to delay or phase these rapid response updates across their own infrastructure, rather than having them forced on globally with zero opt-out. In conclusion, the CrowdStrike outage of July 2024 is a powerful reminder that our security tools must be built with the same rigor and skepticism that we apply to external threats. A single missed validation step in privileged software can undermine global trust and bring critical infrastructure to its knees. Thank you for your time, and this concludes my presentation.